the electroplating is the application. So you have a cell, you have the cathode, the anode, and that there is a transfer of electron, and there's also, in the case of electroplating, there's a transfer of electron and at the same time deposition of a precious metal on the surface of a metal. Electroplating. So if you happen to see a cheap jewelry um, or any jewelry, you should suspect whether it is really pure or it is just being electroplated. So that is an application of our topic for this unit. So in those video, um, you should take note of the following: diatomic elements. There are 7 all in all. Diatomic elements that is taken up in the under electrolysis, and you should take note also the half reactions, the reaction taking at the anode and the reaction taking at the cathode. Okay, cathode is where the reduction reaction is taking place, and the anode it is where the oxidation is taking place. So you should have a drawing. The transfer of electron, you should have the direction. And in that video, they 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 made use of the word pushes electron out. Okay? Hindi yung usual definition natin na where electrons are lost. No. There's a gain of electron. No. Sa video na yon, the presenter avoided the term um, gain or loss, but rather pulls in, pushes electron out, pulls in electron, and for the cathode, he made use of that term, pushes electron out. Okay. So you have your half reaction. One taking place at the one oxidation reaction is taking place on it, and it is written usually on the left, and on the right you have the reduction reaction. So you should balance the equation. In the number of electrons in that oxidation reaction should be equal to the number of electrons in the reduction equation. Before you can add the two equation. Okay. In the electrolysis of water, pure water is not used alone. Okay. There must be some substance that is added into the cell, and that is your sulfuric acid. Sulfuric acid. In the case of your electroplating, what is added there is your silver nitrate. So from the three YouTube videos that I gave you, you should um, you should present me the outline of electrolysis of sodium chloride and water. That is one. So when I say outline, that includes the half cell reaction. And then you should give me a drawing of the cell, you indicate the direction of the electrons. Then number 4, compare oxidation reaction and reduction reaction. Okay. In the case of electrolysis of water, hydrogen is produced. Hydrogen is produced. How is hydrogen gas collected in that case? Okay. So you should give me the answer there. Hmm? Okay. So that is one. And then we proceed with the voltaic and galvanic cell. In electrolysis, electricity is used to separate the compound into its elemental composition. Water will give hydrogen and oxygen. In the case of your sodium chloride, sodium and chlorine atom are produced. Okay? So electrolysis, there's a passage of electricity. Okay? The breakdown of sodium chloride and water is not spontaneous. You have to apply electricity. You know now what is the difference of non-spontaneous and spontaneous reaction. In a spontaneous reaction, kusa siyang nangyayari. Okay? Kusa siyang nangyayari. There's a high possibility that the reaction will take place. So the water will not dissociate into hydrogen and water by itself. Hmm? Electricity has to be introduced. Energy from the environment has to be introduced into the system. The same thing with the electrolysis of sodium chloride. In the case of the voltaic cell or galvanic cell, the reaction taking place generates electricity. One example, the simplest example of a voltaic or galvanic cell are the batteries. Batteries that use you to run your calculator, even your flashlight, and so on. Okay. And then in that in the voltaic cell, there's a tug of war of electron. I'm using the the same term used in the video, tug of war. May mas malakas ang hatak, may mahina ang hatak. Okay. So, the zinc has a weaker pull of electron, whereas the copper has a stronger pull of electron. Okay. In the voltaic cell or galvanic cell, you have a salt bridge. Okay, salt bridge. Salt, anong meron doon? Sodium ion and chlorine ion, which eventually go back to the beaker where the electrodes are submerged. So what are the electrodes? You have the zinc, that is a metal, zinc metal, and the other electrode is composed of a copper metal. And you should know the cell notation. Cell notation. Okay? Cell notation. On the left side, you have a bar. Dalawang bar. To the left side of those bar, vertical bar, you have the oxidation reaction. And that is the reaction taking place at the anode. Okay? Anode. And At the left side of that two parallel vertical bar, that summarizes the cathode. Okay, reduction. So the copper 2 plus aqueous will accept two two electrons, so that it will become a solid copper. Okay, solid copper. It is a neutral copper. Kasi yung 2 plus na balance na nung tumanggap siya ng dalawang electron. Kaya solid na siya. So, you should know how to write cell notation. Okay? Cell notation. So, in the half cell reaction taking place at the anode and the cathode, you have arrows. You add two electrons. Electron is produced. Okay, but that reaction, which we are familiar with writing it, seeing it, okay, balancing it, is now summarized in the cell notation. So the reaction taking place at the anode, okay, there's a bar, single bar, and the product of the reaction at the anode, and then you have the two bar perpendicular, no, parallel siya, vertical sila, and then you have the reaction that is the reduction reaction. Okay, the positively charged ion accept an electron, so that it will appear as a solid on the last part of the cell notation. Okay, cell notation. So that is your activity for today. Out of the three YouTube videos, you summarize them. Okay, you summarize them. You should have a drawing. Okay, you should have a drawing. So that is your activity. Remember that today is a lab day. Our schedule really is 2 to 5. That is a lab day. And talagang online. Although we tried to have it face-to-face for the first time, biglang nagbago yung changes, may pagbabago yung schedule ng ARCI. Nagkaroon sila ng activity sa B5. It's good you inform me ahead that B5 is not really free. Nandun na ako sa Carig. Inuna ko lang ng grocery. Okay? Nag-grocery ako. Paglabas ko, bago ako lumabas ng grocery, tinignan ko yung cellphone, nandun na yung PM ni Cliff. Sir, hindi pala libre yung B5. Kaya ito, I was prepared with my lecture. Okay? Mag face-to-face na, nag-pull out na ako ng lecture notes ko. Face-to-face na tayo. Kaya lang ito. Pero, okay, just the same. We have this activity. You submit now, send me now the screenshot of the attendance, so that you can go on your own. Do you have classes tomorrow?
Yes, sir.
Yes po, sir.
Do you have classes tomorrow?
Yes po, sir. Meron po.
Clarence? Do you have
Meron,
classes tomorrow?
meron po,
I
sir.
cannot hear you.
Meron po, sir.
I cannot hear you. Or you comment na lang doon sa Facebook. You send me down the screenshot of the attendance. So, anyway, I have already discussed uh, the 3 videos, and on your part, submit nyo na lang yung outline ninyo. Okay? I'm just waiting for the screenshot of the attendance. May particle kayo bukas? Particle technology?
Yes po, sir.
Meron, sir.
Okay? If you don't have any question, I will dismiss you now. Okay? Bahala na kayo diyan. At least yung yung kakulangan sa laboratory, I am just supplementing it with videos, experimental procedures on the topic we have. So, do you have any question? No more question?
Wala, sir.
Hindi ko kayo naririnig.
Oh.
Hindi ko kayo naririnig.
Sir, nakamute po yung laptop mo, sir.
Oh, sige, gawin niyo na yung activity niyo, outline niyo ng 3 YouTube videos. Okay? Gawin niyo na, ha? Gawin niyo na. Submit niyo sa Monday sa table ko.
Okay po. Okay po, sir.
Dismiss na tayo.
Bye-bye.
Amoy!
Thank you po, sir. Mama chup-chup.
Bye po. Bye-bye.
Hey, sir.
Thank you
Hindi
po,
ko
sir.
kayo naririnig.
Naririnig kita, sir.